the learner's house. So this is the conditional expectation video on R. So we would do this with the help of a question. We can understand the question from here, and before doing this question or before starting the video, please make sure that you have watched the conditional expectation topic from theory, or you already know the concepts of theory, so that you can proceed that in R. Alright, so let's start. The question says that the number of claims per month are independent Poisson random variables with mean lambda, where lambda has an exponential distribution with mean 0.4. So what this says is, let's say that x is the number of claims in a month, then the x, which is number of claims, this follows Poisson, and the parameter is lambda, where lambda is not constant. Lambda is also a random variable which follows exponential distribution with mean 0.4. So first of all, we have to create a vector values that contain 5000 zeros. So to contain 0, you should know that how do we do that, because this is really important and we would come to it like very often. So part 1, let's do it. Values is the vector we are creating. This is the sign to create a vector. Now we have to repeat. What we have to repeat? We have to create a blank vector. So we can say that we have to repeat 5000 times, and what we have to repeat? We have to repeat 0. So REP stands for the repeat function, and then we would write 0 cause हमें 0 repeat करना है, comma 5000, which says that we have to repeat 0 5000 times. And now we can run it from here, and we can see that this is numeric from 1 to 5000, saying that we have 5000 values, and what the values contain, we can see that there are zeros. You can also run values here if you want, but that's so big and that would spam it. So these are the zeros we have here. So now we can erase it. Now we can do the part 2 also. So first of all, let's read the part 2. This says, using for loop, simulate 5000 values of x by simulating one value of lambda and then using it to obtain values of x. Store it in object values. Here we have to write A. Use seed 40. So first of all, we would set the seed as 40. And how do we do that? We would write the command set.seed, and in brackets we would write 40. Now we can enter and write the next part of the command. So now we have to use for loop command, which you all should know, or if you don't, then you can go to my for loop video before doing this concept. So we would write FOR, for. So what for loop is generally, we write for normally, and then we write I in 1 colon 5000. Why I written this? I is a dummy variable or a temporary variable which I have created here, and 1 colon 5000. What does this say? This says that I have to run this loop 5000 times, and then we would do the curly bracket. We would press space here, not space, enter here, and then we can write the command here. So what we want to write inside the loop? First of all, we want to create the lambda values, and then we want to use that lambda value to determine the value of x, because we have to calculate that. So we would write lambda. What this would do? This would take the value lambda, determine that, and save that into lambda. Okay. So this would do this each and every time we run the loop. So lambda is a random variable which comes from exponential distribution. So you should know that how do we calculate this. REXP is the command for taking the exponential values. For determining that, this is the command. So after writing rext, we have to calculate that how many values of lambda we want. We want only one value. So we can write 1 here and then press comma. And then the parameter value is what we require. So exponential with mean 0.14. So that means that parameter would be 1 by 0.4, because the mean and the parameter of exponential are reciprocal to each other. And then after determining lambda, we want to use that lambda and save that to our x value. So what our x value is, we would store that in values I, and then we would write this. I would explain this whole command once I would write all this. So if you are still not getting it, then wait for few minutes. And then we would write here our poise, because x values are from Poisson distribution. And then we want to write that how many values we want. We want one value here, and then the parameter, which is lambda. All right. So this is it. This is the command. Now we can run this whole command. This says that object value is not found, because we have taken this lower case. We have to write uppercase V. Now we can run this again. The command has finally run. We can see that our values vector doesn't have 0 now. It has so many values, like it has, we can check it, we can press run. So there are so many values, 0, 1, 2, 3. By looking at here, we can get that the values this contain is only 0 or either 1. But this is not the case. We can run the whole value and we can see that there is 3 also, there is 0 also, 1 also, 2 also. Since Poisson is discrete random variable, it takes only the point-wise values and not the interval. Now we can clear the console part. Now let's understand the for loop command again for those who still haven't got it. So first of all, we have set the seed here, and then I have written for. This says for loop, and then I, which I is the temporary variable. We take it to tell R that how many times we want R to run this command. So we have taken 1 colon 5000 here, which tells that we have to take I 1, and then second time the loop runs, we have to take I 2, then 3, and so on. So our loop will run for 5000 times. Then I have written lambda here. So we have how we have done this, and why I have written lambda here, because we have to calculate the Poisson random variable values, and those values will come once we have a parameter, and that parameter is itself a random variable. So that's why first of all we are calculating the parameter value, and then we are calculating the x values. So for lambda I have written rext here, because of the fact that our lambda follows exponential distribution. I have taken 1 here to tell R that I want only one value of lambda. Why I want only one? Because lambda is a random variable. Each time I run a loop, I will get a different lambda, and I would use that different lambda for each value of x. So I want one value, and then I have written this parameter here, which I derived from the question itself. And then I have written values I, values bracket I. What does this mean? Values bracket I. What does this mean? This means that I want to save whichever value will come here, I want to save that into ith value of values, because values vector contains 5000 values. So if let's say that first time when loop would run, then I would be 1. So our first value of values would be r poise 1, and then lambda, and then second value would come here. So first value which we would get by running the loop would be saved into the first value of values, and then into the second values. So that's why we are writing this bracket I. This means that save this value. Alright, so I hope this would be clear now. Now we would do the third part, use your simulations to obtain empirical values of mean and variance. So we have done the simulations and now we have to use the simulations. So let's see how we would use the simulation. We have to calculate the mean of values. So this is how we calculate the empirical values, empirical mean, variance and so on. So our mean is 0.389 and then we can calculate variance by command VAR and then we can write values inside this. Control enter 0.5193829. This is what we are getting here. This was quite easy. Now we can come to part 4th, which says that obtain a histogram of your simulations. Now we can create a histogram of our simulations. So let's calculate part 4th. We have to calculate histograms, determine histogram or plot a histogram. So how we would do that? We would do that with the command hist and then we would take brackets here. Histogram, we have to calculate histogram of what? Of values. So we would write values here and then if we want probability, then we can write probability equals to true. Otherwise we can get frequency also. Now we can run this. So this is the histogram which we are getting. If you want, you can apply breaks or x limit, y limit. If you want, you can do that. You can take the x label, y label or main also. In exam, you should do that because that gains the attraction of the examiner, and also sometimes the marks can get deducted if you don't write these things. So please take care. Now we would do the part 5th. Part 5th says that calculate the empirical probability that there are more than 2 claims in a particular month. Alright, so we know that we calculate empirical probabilities by length. I want length of that what should be greater than this says that calculate the empirical probability that there are more than 2 claims in a particular month. So we have to calculate the probability of values greater than 2. Of values greater than 2. So we would write values. What is the condition we want to impose? The condition is that values should be greater than 2. And now we want the count of these values. So we would write length outside this and then the brackets divided by. Now we would divide this by length of total values which we have. So we can do the capital value here because we had saved that like that. Now we can run this. So we can see that this is 0.0218. So this was it. This is how we do conditional expectation. You can follow this question or you can take up more questions and practice this. So this was it for the video, and in our next R video we will start with central limit theorem. Alright, keep watching, keep learning. Thank you so much.